Hello, I am Francisco Santos and we are going to present our solution to the Kaggle challenge sponsored by 2 Sigma. This Kaggle is called Using News to Predict Stock Movement. We are going to follow these points during the presentation. So, first of all, what is 2 Sigma? 2 Sigma Investments is a company that uses a variety of technological methods including artificial intelligence, machine learning, and distributed computing for its trading strategies. Last month, 2 Sigma started a €1 kilo competition in Kaggle for those who get the best results. This challenge can be solved using either Python or R. We have selected Python as programming language, and we have used some well-known Python libraries like sklearn, pandas, and 2 Sigma News. The last one is a specific Python library for this competition. Also, Kaggle provides big cloud computing machines to run the kernels. The limits of those machines per kernel are 16 GB of RAM memory, 6 hours of total runtime, and finally 4 CPU cores. Apart from that, the competitions use 2 different datasets provided by 2 big companies. Intrinio is the one who provides the market data, and Thomson Reuters provides the news data. During this presentation, we will analyze both datasets in detail. For this challenge, we have decided to follow the CrisDM methodology. CrisDM is a robust and well-proven methodology which provides a structured approach to planning and develop a data science project. During this challenge, we will go through all phases of the methodology, from the business understanding to the development phase, as we can see in the image. All data science projects involve a technical side and a business side. Both should team up and work together to obtain optimal results. After all, we want to answer this question. Can we use the content of news analytics to predict stock price performance? In this competition, we will try to predict how a stock will change based on the market state and news articles. The ubiquity of data today enables investors at any scale to better make investment decisions, and also could help predict financial outcomes and generate significant economic impact all over the world.
Okay, as my partner Frank has already explained, there are 2 big datasets for this challenge. We have begun studying the what discusses the financial information. It is more important because it contains a target variable. Many other challengers have just proposed a solution just by using this only dataset. Market data contains financial information such as opening price, closing price, trading volume, calculated returns, and they are all related to different periods of time. It is a huge dataset with over 4 million of rows and 15 variables, and return open next MK trees 10 is the column that we will try to predict. The first thing we did in order to understand our data was to compute the matrix of correlations, and we are going to show them in a correlation plot. We can clearly see that returns open next NK trees 10, which is the target variable, does not correlate well with any other variable. We observe also a high correlation between row and NK trees, which also makes sense, because it is almost the same variable but just with a little correction. In order to try to understand well what we were trying to predict, we draw the temporal series of 5 big companies. When we saw this huge fall for the prices of Apple, we thought that the data may be wrong, so we searched on the internet what was happening. What was happening is that there was a big split for Apple stock price in June 2014, because they wanted to make their prices more accessible to regular people. In the graph of the right, you can see this data without the Apple prices. After all of this, we make the study of the target variable. We have plotted the returns open next MK310 for the same 5 assets. We can clearly see that Bank of America is the asset with a higher standard deviation, and that the positive and negative parts are more or less equalized. This last result can also be seen with the little value of the mean we get. We have plotted the distribution of the variable with an histogram, and we have computed some statistical values, such as skewness and kurtosis. We can see that the values of those statistical properties are consequent with the drawing of the variable, since it is a very sharp Gaussian distribution and pretty symmetric also. After that, we make a study of the news dataset. It has more than 9 millions of rows and over 35 variables, and it contains information about news, articles, and alerts published about these assets, such as article details, sentiment, or any other commentaries. We have studied deeply two variables that seem to be the most important variables of this dataset. We wanted to understand what does relevance mean. We have computed an histogram and we can see that most of the variables are set to 1, and this has helped us to understand the importance of this variable. We have also made a sentiment pie chart. We can see that these three columns have a sum equal to 1. So we compute a mean over each column and we have plotted them in a pie chart, as we can see in the graph. The most common sentiment is the neutral sentiment, and it is closely followed by the positive sentiment. With this, we have finished the data understanding part.
Our next step in ChrisDN methodology is the data preparation. The first part is the data pre-processing, in which we choose the variables we will apply in the model. The range or normalization will apply, and the data transformation for work with it. The first is the time. We focus in the data market for first, where contains financial market information, as you can see. We start with the time variable, which is given in the long format of UTC standard, and we transform into a year, month, day format because it's relevant to maintain the hour and the time zone model. The next, one of the most precious variables, is the asset name and the asset codes. This last one can have many different identifiers for the same asset name. We have the example of a well-known company, Apple, which has different code for every index in which participate. For the easy to use of companies, we transform each asset name into an integer. The next, as my colleague said before, the universe description, we discard it because it's not given for the prediction. For the next, we have closed and open market variables, so we just use as they give to us. For the next one, we have the returns variables. So we can differ in 4 types. The data type, so we can differ from raw data and the data respect to the market. The date range from 1 to 10 days. The market value at opening the season or at closing the season, and where is the data record refer, if it's previously or if for the next 10 days. This is what the variable we will try to predict. And we finish with the market variables, so we will start with the news variables. As my colleague said before, we have a lot of variables, but we will focus on the novelty and volume counts. They are the ones we transform, and we transform every novelty count different time into a novelty count list, and the same with the volume count list. And for the preprocessing, we use as for the same time and same asset name, we will merge it, and for the different variables, we will make an operation on it. For the urgency, we will make the max of each of it, and for the rest, we will use the mean for each one. So we get more or less a good result. That makes or size data before transformation more than 9 million, transforming into a more or less 2 million.
Okay, so for the modeling part, before performing our different models, we have to select which variables we are going to use. For the first time, we used all of them except time. But after the exploration we have commented before, we decided to keep just the market variables, excluding the variables in the news dataset. After that, we chose 2014 and 2015 as the year selected for our training data, because otherwise the execution time will be really big, and we consider this data the most recent and reliable data. For the test part, we have used 2016 and part of 2017. We have reviewed the sklearn library and looked for the best models that could fit our problem. Finally, and after trying some models such as linear regression, we decided to choose gradient boosting regressor and random forest, as they gave us the best results that we are going to present later. The next step is to validate our results. For the Kaggle competitions, you must make submission directly from Kaggle kernels by automatically calling a specific method. There is no need to manually create your submissions. Submission will have the following format: time, asset code, and confidence value, which goes from -1 to 1. And if you expect a stock to have a large positive return compared to the broad market over the next 10 days, you might assign it a large positive confidence value, near 1. And if you expect a stock to have a negative return, you might assign it a large negative confidence value, near -1. If unsure, you might assign it a value near 0. Your submission score is then calculated as the mean divided by the standard deviation of your daily XT values. If the standard deviation of prediction is 0, the score is defined as 0. The final results for both models are described in the following slide. As we can see, the random forest regressor gives us worse results than the gradient boosting regressor in both the mean absolute error and Kaggle metrics, but it takes us much less time.
Okay, so to end with, I will show you a demo of the notebook in which I followed all the steps provided by my colleagues. First of all, we do the imports of the libraries and the loading of the data by making use of the libraries provided by the Kaggle competition. Then we start to analyze the data, starting with the market data. First, we can see all the types, the correlations, and also the analysis of some variables. For instance, the closing prices, the number of null values, and how are they in the dataset. For instance, we have 4 variables with null ones, so we will replace them with the means. And then some other analysis like the target variable. We did basically the same with the news data, and after all, we will just basically merge both datasets. But for what? First of all, we have to merge all the news from the same data and assets. After all, we got the final dataset, and we will take it for the modeling part. For modeling, we took the dataset for train and for test, and then we tried some models, and here we have the final results. And here, for instance, we can check how is the real target variable and what we predicted, so we can see that more or less it worked. And here in the last part, we will predict for the final validate dataset, but we haven't got here the results because they are not provided directly by the owners of the data. So in general, we would like to highlight that the competition was really difficult, and that we had to perform plenty of analysis and transformation with the data, and finally to get a prediction that was not really encouraging. And also, Well, we had some troubles with the Kaggle kernel limitations like CPU and memory that also forced us to think about